Okay, today we're going to be talking about inverse functions. And just a reminder, the definition of function f of x is 1 to 1 on the domain if f of x sub 1 is not equal to f of x sub 2 whenever x sub 1 is not equal to x sub 2 in the domain. So basically, the x values of the ordered pair do not repeat. When the function's 1 to 1, the y values do not repeat. So if you think back to algebra, how did we determine if a relation was a function? What was the test that we used? Vertical line test. Good. So when we're talking about inverse functions, does a function have an inverse? We use the horizontal line test right here. So just a couple examples down here. If I do a horizontal line, it's going to touch the graph in two places. So let me draw that in red. So if I drew that, you can see it's going to touch, so that would be not 1 to 1. Okay, over here, if I drew a horizontal line, it's only going to touch in one place, so we would say, yes, this is 1 to 1. Over here, number 3, you can see that two places, so it would say no, and here, if I do a horizontal line, one time, so yes, 1 to 1. So basically, we want to, a function y equals f of x is 1 to 1 if and only if its graph intersects each horizontal line at most once. Okay, so that's just a reminder from algebra. And another theorem, here's a page with some theorems on them. So they're inverses of one another if the domain of f is equal to the range of g, and the range of f is equal to the domain of g. So this is kind of vice versa. So we want to keep that in mind. And so this is also let f be a one-to-one function with the domain d and the range r. If g is a function with the domain r and the range of d, then g is the inverse if and only if both of the conditions are true. So the g of f of x is equal to x, and also the f of g of y is equal to y. Okay, and just a kind of a brief summary of that is theorem 7.4. The domain of f inverse is equal to the range of f, and the range of f inverse is equal to the domain of f. Just to see a quick example of this, let's say I had my function f here, and it had ordered pairs 0, 3, 1, 2, 2, negative 1, where the domain are the x values, the range are the y values. Then the relationship that these two have, if this is the inverse of f, then you can see that the domain of f inverse, right here, is equal to the range of f. Let me highlight that. So the domain of f inverse is equal to the range of f. Okay, that's this first portion. And then if I change colors, the range of f inverse is equal to the domain of f. So that's an easy visual for that, very basic. Okay, so the next thing we're going to do is we're going to look at some guidelines for finding inverses. So just to kind of give you some steps, first of all, you're going to make sure that it's a one-to-one function. Then you want to solve the equation y equals f of x for x in terms of y to get it in the form of x equals f inverse of y, and you'll verify the two conditions. We want to verify that the f inverse of f of x is equal to x, and f of f inverse of x is equal to x, which is this particular theorem. So let's see an example of this. Okay. For that, the first thing we're going to do is practice an algebra problem. So let f of x be a given function, and it's going to be 3x minus 2. Well, the first thing I'm going to do is rewrite it as y equals 3x minus 2. Remember, f of x is the same thing as y equals. Now, in the steps for finding this, we want to interchange our x and y. So let's interchange x. Everywhere there's a y, plug in an x, and the same. So first thing you want to do, and let's make a side note. So we're going to interchange x and y. Okay, and the next thing we're going to do is solve for y equals. So let's get y by itself. So let's add 2. That would give us x plus 2 is equal to 3y. Divide both sides by 3, so this is just going to be x plus 2 divided by 3 is equal to y. And the last thing you want to do is just replace y with f inverse. Okay, so that ends up, when we solve this for y, that ends up being our f inverse. So this is the inverse. If f of x is 3x minus 2, this is the f inverse of x, which we'll do f inverse of x. Okay, now that's the inverse, but now we got to verify the condition. So the next thing we want to do is verify that these two conditions are true. So we'll do that on the next page. Okay, on this next page I have it set up, my given functions, my f of x, what we solved to find our inverse. Now we want to verify that these meet both of these conditions. So we're going to start with that. So the first thing we're going to do is we're going to plug in, work from our inside out. So let's plug in f of x. So we have f inverse. What is f of x? 3x minus 2. It was our given, right? Okay, now we want to plug this in our f inverse function, which is here. So everywhere there's an x, we want to plug in 3x minus 2 in that. So basically, go to your f inverse function and put a parenthesis. Let's just do this. Put a parenthesis everywhere there's an x. Right? So go to your f inverse function, that's here. Everywhere there's an x, put a parenthesis. So put a parenthesis, and now let's substitute this 3x minus 2. Okay, so that's how we will evaluate that. Okay, what is a negative 2 plus 2? These two cancel each other out, so we'll just be left with 3x divided by 3, which is just x. So this left-hand side, this checks. That does equal x. We want to see if this right-hand side does as well. Okay, just like we did over there, we're going to start with our inside function. So our f inverse, we're going to plug in with that. So we'll have our f inverse of x we solved for and got this value. Okay, to evaluate f of x plus 2 over 3, we go to our f of x function, and everywhere there's an x, put a parenthesis. So let's do that. So 3, let's put a parenthesis where the x is, and then now we're going to plug this value into here. So we would have x plus 2 divided by 3. Okay, now we can go ahead and start simplifying. This 3 will cancel this 3, and you'll just have x plus 2 minus 2, and then those 2's cancel. So this just gives you equals x. So we can say thus inverses. So these have checked both conditions and are inverses. Okay, now that you've had a little bit of practice and been reminded of one, if you want to go ahead and attempt this one. Now this one has a condition. This is just going to be it's restricted to the side that x is greater than or equal to 0. Okay, so rewrite this as y equals, interchange your x and y and solve for y equals, and then replace that with f inverse of x. Go ahead and attempt that. Okay, so we rewrite it as y equals, then we're going to interchange our x and y variables, solve this for y equals. Now when you get here, when we get to this y squared, we take the square root of both sides. Don't forget that you get plus or minus the square root of x plus 3. And then last step, rewrite this as f inverse of x. Now we only keep the positive one. Since x is a non-negative value, we reject the negative portion of it, because this right here says x is greater than or equal to 0. We want the positive x value, so because of that condition, we reject the negative value. Okay, I have you set up on the next page. So basically we have our f of x, which was given, our f inverse, which we solved for, and we want to verify the two conditions. Okay, we can see that this left side, this first condition checks out. This portion right here, if you have trouble, it's here. So you go to the F inverse function. Everywhere there's an X, put a parenthesis. So that's what we did here. And then you plug this into the parenthesis and solve. And remember, we're going to remind ourselves of our condition that it's only for X greater than or equal to 0. So let's do the other side. Okay, so we could see that this side checks out as well. I'm going to draw a rough sketch of these two graphs on the next page so we can look at the comparison of that. Okay, just taking a look at a rough sketch of this. Now this isn't to scale and I don't do the best jobs of drawing these things out, but basically this is our y equals f of x function, and I just plotted some ordered pairs on here so that you can easily see the relationship there. This, of course, over 3 up 6 is not to scale by any means. I just kind of threw that up there so we can get that number in, but 3, 6 is the actual ordered pair. You can see that the f inverse function is this black one, and another characteristic of inverse is it's symmetric about the equation y equals x. So if I drew a dashed line through the two of those, you could see if I folded it on that dashed line that they would be symmetric about that equation. Okay, I want to show you that for this one, our original function, if x is greater than or equal to 0, because that was given in our original equation. So our f of x, we said for the x values greater than or equal to 0. But what about our f inverse function? It'll be for x values what? Greater than or equal to -3. So that's why I went back and put this information here just so that we can see that. Okay, so the image kind of helps bring it all together. So your f of x for the values x is greater than or equal to 0, your f inverse of x for x values greater than or equal to -3.